Hi all, Bones here from BSA Bantams, and welcome back to the workshop, welcome back to the channel. In this episode, it won't be the race bike. I've actually got to catch up on some Bantam stuff. So what I've actually have to do, I've run out of plunger rear wheel nuts. So what I'm going to do is show you how I set up this 100-year-old turret lathe to produce some of the things that we produce. So I'll give you a rundown on the machine and I'll just take you off the stand and we'll go handheld and I'll show you what I'm up to. So this is my trusty Ward #1 turret lathe. So if you don't understand what a turret lathe is, this thing here, which is usually a tailstock on a normal center lathe, is a turret. So every time you wind it back, you can index another tool around, like that. I'll just take that out of there. So in here, this is what's called a collet chuck. So to close up on the job, you only have to operate this lever. Now that's a collet in there. It gets drawn back in on a taper and it closes up. But I'll show you this a bit later. So this machine was built somewhere in the late 1920s. It's a fantastic old machine. And it's the type of machine that would have mass-produced a lot of the parts for the BSA Bantam. So what we're actually making today is plunger rear wheel nuts. Now there's a good reason I make these, because the ones you get that are reproduction are crap in a nutshell. So we've chosen to produce our own. So I'm about to start setting this machine up and I'll show you how I go about it. So first item on the agenda is to actually take the collet out, and I'll need a spanner for that, which is here somewhere. Here it is. So just use a pin spanner. Oh, actually, I've got to undo the lock nut in there. I'll bring it back. So I'm just undoing this little grub screw that lives in here, which holds the collet, this collet nut, in the right position. So we'll just give that a little bit of a snap. Like we go. And we should be able to unscrew that. Might need a bit more. Just drop that there. And this is the collet. You can see it's split through here. That's the taper that when it gets pulled back, it closes up on the job. So this one was for a bit of 3/4 inch bar stock. Because I'm doing wheel nuts, I need to go and find the one for 1 inch hex. So what I'm doing now is that I don't have a collet, a 1 inch collet. I just realised that for this job, I have to actually put a 3-jaw chuck in. So what I'm doing is just taking out the collet chuck assembly and replacing it with the 3-jaw chuck. So this is the spindle that holds your collet, and there's got ball bearings around in here. So when you pull it back, they actually ride back and actually close up on the collet in here. So I'll just get this out. We'll get the chuck in. So what I'm doing now is fitting up the adapter plate. So this plate I'm bolting on now allows me to set up a 3-jaw universal chuck on this machine, which wouldn't have had one in the first place. So obviously these three bolts sitting out here for bolting the actual chuck on, but it's a little bit ticky touch getting this on, but it's all right. I've done it a fair few times. So we'll get this on, we'll get the chuck on. So as you can see, we've got the 3-jaw chuck in. What I'm going to do now is I'm going to put some bar stock in there, and the first job I'm going to do is set my stop, and that will then allow me to see about the position of the actual whole tailstock assembly, because I can move the whole assembly up and down the bed of the lathe. So I've got a chuck in, everything's going great. Take the lock off. What I'm doing now is just machining a bit off the face. So I've got a nice clean machine surface. I've got a nice clean machine surface to set my stop and start everything off. Facing cut. And stop it. So there, I've got a nice clean machine surface, so when I bring the stop back around, I've got a nice clean face to start setting everything to. Now obviously this tailstock needs to move back, so I've got clearance for drills and things like that that are going to be in here. So what I'm doing now is just repositioning this. Now as this index is around, I'm going to have drills hanging out, so I've got to have enough clearance, because you can see the lines here where I've hit drill bits before. So I think I need to come back just a fraction more, and then there's bolts in under here that we just clamp this up in position on the bed, and we'll go around and lock this up, and hopefully this will be the right position. Right, that looks a bit better. Rightio. Now we can set the stop, and we'll do that over here. So right in here, this thing here is the stop for the carriage moving that way. So it comes up, wind it out of the way, and you've got adjustment nut and everything there. So I'll just move you up. Over here is the parting off tool. So I set the parting off tool in my position. Undo that. So I don't obviously contact the chuck. So I'll set it right there. I'll lock that up, and now I can go back. It's locked up. Now I'll go back over the top, and I'll show you what's happening to set the stop in the tailstock. So from my drawing up here, I have 5/16 and a bit over 1/2 inch. So that is 5/16, 2, 3, 4, about 3/4 of an inch. A bit more. So this is just a rough setup at the moment. So what I've got to do is have enough overhang about 3/4 of an inch there. So this is my first initial setup for the stop. Now the stops, that's as far as it goes, so I have to go back up to the end and start adjusting that up. So what I have to do now is, this has got a lock nut in here, undo that, and then I've got to wind this out. I've got to wind this out, this nut, so the actual tailstock can move forward. Like that. So we'll move it all the way up until it hits the stop. So what we're looking down on now is that's my parting off tool there. I'm just going to rotate the chuck around so I can get my parting tool in closer, like about there. Then I'm going to use my vernier calipers, and I'll turn them on and zero them, because this is our drawing up here. So you can see our lengths are 312 and 0.55. This is in thou, so that's 862 thou. So this is where I come back here. Just wind that out just a fraction so I can get the verniers in there, and I start measuring. And we have, if I put it on, excuse me for a sec while I put it on imperial. So we measure that again, have a look, and we have, oh, what's going on? Try that again. And we have 813 thou, so I've got another, it's got to protrude another 50 thou. Just make sure I'll double check. Oh, something's going on with my verniers. Right, I just worked out what's happened with my verniers. The off button's hitting this when I'm going to adjust it. So that's our length there. We have 894, which means that we are 32 thou too long. So this is where I'll go back and I'll adjust this in 32 thou. That'll give me my overall correct length through here. So I have my dial indicator set up there. I'm just going back down to here. My adjusters, I'm going to wind this out. Go back to here, push it a little bit forward. Oh, too far. That's, well, oh, that's 0.84. So I'm just going to go back here, and with the spanner on, I'm just going to tighten it up, and this should bring it back like that. Now I'm going to lock it up in that position down here with the lock nut. So I'll wind that in, lock it up, take the tailstock away, come back again and see what it measures. Right, I've lost 0.1 of a mil in that adjustment, which is 4 thou. So what I'm going to do now is unlock again, back it off a fraction because it's obviously tightened it up when I tightened it up. Leave that hanging there, wind this back out. I've gone too far by 4 thou. I'll back it off again, wind it in a fraction, lock it up, back to here, back to there, and that's within 0.01 of a millimetre, which is fine. You know, that's half a thou. Half a thou on a wheel nut's not going to make one iota of difference, so I'm pretty happy with that. Now that I've got that done, it's time to go here and start setting up tools in here. So in here we'll have a centre drill, here we'll have the tapping size drill, and in that drill chuck there we'll have a chamfering tool for the thread. Oh, I'll just move that out of the way. Sorry for going handheld. We'll see how we go. Now, I've got to go 0.6 of a millimetre on here to get my correct shoulder length. So we'll just turn the machine on. And I'm looking at this. Stop there, I'll wind out. And the most important thing is I will move, there's a pointer that comes around on here. I can't show you because I don't want to move it, but I'll show you once I have repositioned that. So there's my little pointer there. So that now sets my depth of shoulder. So down there is the stop for the parting off tool. This will be the indicator for the length of the shoulder. Okay, so we are well and truly into it. The only adjustments I've had to make was I actually set, and the drawing's wrong, I've actually set up the shoulder length too long. I had set up the shoulder length too long, but I've rectified that. So what we're going to go through now is the whole process. So I've just finished parting one off. So this is what I have to actually do. So we've got to move the bar stock out. So we're going to take out our parting off tool, put in our turning facing tool, and we're going to put it into a park position out of the way over here. And the reason for that is so all the tools in the turret can actually index around. So pull that out, we'll get our stop coming around. And we have to be very careful because we do have a long overhanging tool there, being the actual drill bit. So it just clears the handle, so don't have your fingers in the way, otherwise they get bitten. Right, we push up the stop. We close it off, and now we're ready to go. So turn the machine on. First process will be center drilling. So as with all center drilling, this is a guide for your normal drill that hits the stop. In with the drill. Right, so this is a 1/2 inch drill bit, 12.7 millimeters, which is the tapping drill size for the 916 BSF thread. We have to cut up the middle of that, which is the plunger rear axle diameter. And obviously if we're doing wheel nuts for a rigid, it'd be the 716 BSF, like the front wheel nuts. So we'll just, this one's not set on a stop, it's actually set up on a couple of lines just here, and the reason for that, I couldn't adjust the stop out here because the tool's so long. So because the depth of the hole isn't critical, we can just have a couple of lines here. And I'm not shoving this drill in too hard because I want a half decent finish up the middle and it prolongs tool life. So I'll wait for all the lines to line up. We're at depth. Now this is a chamfering tool as the lead in for our tap. Will actually be the lead out on this side. And what we're doing now is actually turning the shoulder to diameter. So on the cross slide here I have a mark, and we are doing it all in one cut down to depth. That's about nearly, if you count the points of the flats, it's about a 10 mil cut in one hit. So if you've watched any of my other videos about this machine, you'll know it does not have power feed. I have to feed it by hand. So we're coming around to our marker here. Just will just bring it in. You'll see the marker coming around to the line. Out she comes, that's it. So we'll bring the tool out of the way because I've got to change it out to a parting off tool. But before I put the parting off tool, I'm just running a little radius on there, like the original ones were. Parting off tool in, and now we're going to use this tool over here. It's going to put a tiny chamfer on the inside. Just take the edge of the points of the flats off so they don't chew up your chain adjusters. We've got a mark here and we've got a mark in our carriage, so you'll hear it just as we just kiss all the hex coming up about now, and that's all we need. And down here, right down here is our stop. So we rotate that in, lock it, and now we're going to part off. Might be a bit hard for you to see with my hand in the way, but I've got to have it in the way to hold the coolant into the parting tool. Here we go. So here it's changed noise because it's cut through the points of the hex, and now we're cutting a full diameter around. As soon as I've got to do this left-handed, it's a little bit of a challenge. We still keep feeding it gently. Now what's happened is I'm not happy with the surface finish of the parting off tool, so I'm cutting this a bit longer on the head because I'm going to put it back in and face them off so we get a nice finish on the head of the head of the nut. There she goes. We go fishing it out. Blow it off. And that's it. And we'll keep going. So from here, this is just the blank. So these have to go back in, turned around. They'll be faced off, they'll be chamfered, and then we'll run the tap through it. So we'll show you that. Well, it'll be in just a minute on the video, but it won't be. We've got about another hour or two to go on this at least. Righto, we'll be back. So we've ended up with close to 90 nuts from the bar stock that I had. So as you can see, I've changed the setup back to a collet chuck. And this way I can face it, chamfer it and tap it all in the one setup, and then with the lever you just open it up while the machine's still running and you can change them over without even stopping the machine. So going through this side will be a lot quicker than what the original side was. So because we've taken the drill bit out, I have to move the tailstock assembly closer in because I've run out of travel to be able to come in on the stop. If you just see, that's the stop right there, and that's the adjusting screw, so that comes up and hits that stop. So I've run out, so I have to move the whole tailstock assembly that way. Righto, so as you can see, we've taken the chuck out, we've got the collet chuck back in, and so this is the process to do the reverse side and cut the thread. So what I'll do is I'll show you that we'll actually start it running, and with it running I can actually put a job in. So our first job is to face it off again. Now the carriage is in a parked position against the stop with the carriage locked. So I think I mentioned earlier on that I was unhappy with the surface finish from the parting off tool, so we've elected to face it. That's tool back into the parked position and locked. If you're wondering why there's cans over the back over here, this is the reason why. So we just put a dab on our chamfering tool, because of the speed it's turning at can knock it around a bit. So in for the chamfer, and here's the big one. So over here I've got my finger on the reverse button ready to go because the tap goes in pretty quick, and here we go. Machine reverses back out, and then I hit forward again to get the machine rotating in the correct direction. Blow off the small of our tools. We're going to index this all the way back around. So that puts our chamfering tool back in its parked position. Off we go. And there's our job done. So you can see a tiny burr on here. We'll just wire buff that, and that'll knock that burr off. So our little chamfer on the edge there, but no chamfer on here. So this is exactly the way they were made at the factory. So that's basically it. That's the end result. So all our wheel nuts are now done. Time to give the old girl a really good clean down for the next job, which I'm not sure. I'd have to have a look at the list. I've got a sneaky suspicion it's D1 brake rods, but we'll give it a good clean off, get all the, because it's had coolant on it, so we've got to get underneath the slides, heaps of oil. But I thought I'd show you something, and this is the reason why we make those ourselves. Over here on the bench, hopefully it's in focus, these are original wheel nuts. You can see how they're consistent in the height. I'd show you with verniers, but it's a bit hard to actually read the vernier because I can't get the camera close enough. But you see they're all consistent thickness on the hex. You can see they've got a little chamfer right on the corners here. You can see they've got a radius and a chamfer on this edge here. So we'll go and grab a couple of the ones that we've done, and we'll set them up here. So as you can see, same height, same thickness on the hex, radius on the corner, tiny chamfer on the corner of the nut, no chamfer on the back, this edge here, because I didn't have one. And now I'm going to show you a reproduction one that I purchased from a wholesaler in the UK. So they've aggressively chamfered both sides. There is no radius on this edge here. Hopefully you can see that. It's thicker in the width of the nut. It's shorter on the shoulder. Not even remotely close to what the original was. Now yes, I could have put a chamfer on the back of the nuts we make, but we're trying to faithfully reproduce what the original part was. Now, if someone really wants a chamfer on the back, they can put it in the lathe and put a chamfer on it, but we're trying to replicate and make reproduction parts as they were originally made. But look at that. I paid for that. Well, in more ways than one, because I can't really sell them because they're not much chop. Now the interesting thing is the chatter in the thread is absolutely appalling. Like, it's really is crap quality. Hence that's why we make our own. The other thing we've got on the go in the workshop at the moment, this is Justin's job, is sprockets. We actually make our own sprockets. We have them laser cut, and the reason we have them laser cut because it gives you a bit of a flame cut edge. That's good for wearing. We machine the edges, and Justy's just going through and opening up the holes to 1/4 inch clearance for doing bolts, to take the bolts rather than the original rivets. That's half of them, so that's for like D1s through to D5, and we're doing a batch run of D7 on as well. Some more sprockets there that we're doing. So, how many parts do I actually make? When I'm forecasting and doing a production run of components, I work out a 2-year supply. So I have historical data about sales for individual components, so I can have a look back and see how many we've sold. So that sets how many I make. Now there's no point in just making like 10-year supply worth, because A, I've got to store them, and B, I've got to outlay more money for material as well. So the most cost-effective way I've found is always generate around a 2-year supply, sort of plus 10% as a bit of a fudge factor. And the reason for that is I find that there's parts do increase in sales once people know that we've actually got them. Look, I really hope you've enjoyed this video, this insight to one of our production runs of the parts we make here and why we actually make the parts. As you saw, some of the reproduction stuff is absolute crap. So there's no point. Like I said, we're trying to faithfully reproduce parts as they would have been made in the factory, and they would have been made in the factory on one of those machines. So the old 100-year-old girl does a fantastic job, as you can see, and it gets a lot of work. It gets an awful lot of work. So I really hope you've enjoyed this video. Please hit like or subscribe, and next video I think we might be back onto the race bike. We've got a couple of other little jobs to do. But also, before I go, this is a lot of people say, oh, like we do engine rebuilds and things like that, but we also have to allow time for parts manufacture as well. So that's why we can't bring in as much workshop stuff as we probably would like, because we just haven't got the time to do it, because we're making parts as well. So from Bones at BSA Bantams and Justin, we'll see you later.